Today we're doing notes 3.5, factoring by grouping. So we're going to be using the distributive property to help us factor polynomials. So now the key is this only is going to work for us when there are 4 terms. So if there's not 4 terms, we're not going to factor by grouping. So again, this is factoring by grouping. And again, it only works if there are 4 terms. So example 1, we're going to factor by grouping. So basically what we're doing is we're looking for common GCFs that we can factor out. So if I look here at this expression and this expression that I just underlined, I see that they both share an x minus 2. So that is a common factor. So I can factor it out. You're just not used to seeing that. You're used to seeing it be an x or a 5 or a 5x squared. You're not used to seeing your GCF as a binomial. So this is really different. So if I factor out an x minus 2, what would be left is x plus 3. So what we're practicing right now is like the second to last step for factoring by grouping. So if we go to this next example here, right, I look at these two grouping symbols. They're very similar. The only difference is it's a positive x cubed versus a negative x cubed. So if I factor out a negative here, right, change these signs and make this a positive 1. So now x cubed minus 2 is the same thing as negative 2 plus x cubed. Right, those are exactly the same. So I can factor that out. And what would be left would be the 4x plus 1. So in that case, by factoring out a negative, changing the signs in the second grouping symbol, I had an actual common factor. And again, the key is understanding that your common factors when factoring by grouping are going to be binomials. That's extremely different. We haven't seen anything like that. So as I'm sitting here and I'm looking, I see x plus 2, 2 plus x. That's the same thing, right? You could write this as x plus 2. So each expression here, underlining in red, share a common factor. It's x plus 2. So if I factor out an x plus 2, what would be left would be 5 minus x. So this is the step for a lot of students. It's kind of confusing because you're factoring a GCF that you're just not used to seeing. You're not used to seeing it being a binomial. So example 2, right, factoring by grouping. First off, how do I know I can try factoring by grouping? Because there are 4 terms. There has to be 4 terms, otherwise it's not going to work. So what I'm going to do is I'm going to group the first 2. And I'm going to group the last 2. So I'm going to make 2 groups. This is why it's called factoring by grouping. And what I'm going to do is I'm going to take a GCF from the first 2 terms here. So let's see. I can take out a 2 and a b squared. Right, so what would be left would be 3b plus 4. And I want to check, if I distribute this back in, do I get my original 2 terms up there? Yes, I do. Right, 6b squared, so 6b cubed and 8b squared. So I'm good there. So that part I did correctly. Right? Okay. So now what I'm going to do is I'm going to now factor out a GCF from the second grouping symbol, the second 2 terms, so the third and fourth term. So I see that I can take out a positive 3. That would give me a 3b plus 4. So now this is basically what we just practiced 3 times. In order to factor by grouping, when I get to this step, these expressions have to be the same, exactly the same. Otherwise, you can't factor it by grouping. So they're both 3b plus 4. They both share a common factor. So now I can factor that out. So if I take the 3b plus 4 out, what would be left would be 2b squared plus 3. And then I check, because sometimes I could miss and there might have been a GCF. There's nothing there. There's not a difference of squares. So I'm completely factored. So all of our factoring methods that you've learned we reviewed in this class and you learned in Math 2 still apply. You could still have a GCF, you could still have a difference of squares, you could technically still have a difference of cubes possibly, not too often. So you got to be careful with that. Okay, let's move over here. So again, I see 4 terms. So I'm going to factor by grouping. I'm going to try that. Group the first 2, group the second 2. So then I'm going to look at the first 2 terms here. Is there a GCF? Usually there will be. So I see a 5 and a y cubed. So what would be left would be y minus 5 goes into 15 3 times. So now I go to the second set of grouping symbols and see if there's a GCF. I see that they both share a y, so plus y. So what would be left would be y minus 3. Okay, and then next step would be there's a common factor of y minus 3. Factor that out. So if you factor that out, it's basically like this is disappearing, right? What would be left? Well, that would be the 5y cubed plus y. Now I told you we can still have GCFs, we can still have, difference of squares. I notice here there's a GCF, so I want to factor that out. The y minus 3, there's nothing wrong with that. But here, in that second group there's a y. So I can factor out a y, and you get 5y squared plus 1. Now, right now, that's probably freaking a lot of you out because why? Oh my God, are you kidding me? Why'd you put a y in the middle? Like, why would you write it like that? The good thing about multiplication is it's commutative, right? The way once you multiply does not matter. So if you wanted to, this would be a correct answer. Or you could put the y out front. Right? That would be a correct answer. Right? That's good. That one's good. You could get real crazy. Right? And you could put the y at the end. Right? All 3 of those with stars are technically correct answers. The one that you'd most likely see would be the one I'm circling here in purple. That would be the one that you would more than likely see. With the y first, so the monomial, binomial, and then the binomial with the square. But any one of those that are starred would be an acceptable answer. Alright, going to the next one. 4 terms, so I'm going to group the first 2, group the second 2. GCF from the first 2 terms, right? 2x squared. So I get x minus 6. Now, GCF from the second 2 terms. Okay, I see they share a 3. Right, so I know I can take out a 3. Okay, well if I take out a positive 3, that would be a positive 6 minus x. If I took out plus 3. That and that are not the same. X minus 6 and 6 minus x are different. So what I really need to do is factor out a negative 3, which changes that to minus 6 and that to plus x. Now, what's in the grouping symbol is identical. So, when you end up with a case where they're very similar, often it's factoring out a positive or negative is just going to change the signs. So if I factor out this now, right, this factors out. So x minus 6, you'd have 2x squared minus 3. And then, again, that's not a difference of squares. So this would be your factored answer. But again, all of this only works because you're having 4 terms. So you're going to see you're actually doing multiple GCFs. Okay, so example 4 is now we're going to factor and sketch. Because remember, most of this unit is about being able to graph polynomial functions. So we learned how to factor. Now we're learning how to factor by grouping. We'll learn a couple other tools to help us sketch the polynomials. So we're going to factor by grouping. So I'm going to group the first 2, group the second 2. There's a GCF of 2x squared, so this would give you an x minus 5. take a GCF from the second 2, right? I'll do minus 2. That'll give me x minus 5. Now I have a common factor. So factor out x minus 5. You'd have 2x squared minus 2 would be left. However, 2x squared minus 2 has a GCF of 2. So I'm going to factor out that 2. I want to put it out here in front. Don't freak out. It's okay. Multiplication is commutative, so I can put that 2 out in front. Oh, look at that. That's a difference of squares. So this would be 2 times x minus 5. Then you have x plus 1, x minus 1. So now the part here in red is fully factored. That's in factored form. What we started with was standard form. Just like we did in section 3.4. We have to go from standard form to factored form. There's different ways to do that. Regular traditional factoring and now factoring by grouping. Those are our 2 ways to try to get it to factored form. Okay, so still haven't found what I need, right? I need my X-intercepts, my Y-intercept, and my end behavior. So I'm going to let this equal 0. So x minus 5 equals 0, x plus 1 equals 0, x minus 1 equals 0. So you get 5 comma 0, negative 1, and 1. Those would be your X-intercepts. Now some of you are like, well, why don't you let 2 equal 0? Well, 2 is constant. It doesn't vary. The x varies, so that's why we're solving. 2 will always be 2. It's never going to be a different number. X can be any number it wants to because it's a variable. So now I have my X-intercepts. Okay, I need my end behavior. So let's come back up here and look at the original problem. It's in standard form. So 2x cubed. So it would be odd, positive, so it would be low to high. Remember, standard form, it's easy to find the end behavior because you look at the term with the largest exponent. That's the leading term. And it's to the third, so it's odd. It's a positive 2, so it's positive. So now I have the end behavior. I have the X-intercepts. Last thing I need is the Y-intercept. So to find the Y-intercept, right, let's pick, I don't know, let's go red. Right, I'm going to let x equal 0. So I'm going to plug in 0. X is going to equal 0. So you're going to get 0 minus 0 minus 0 plus 10. So the Y-intercept is 0, 10. Right, to find the Y-intercept, you let x equal 0. So now I have everything I need to sketch the graph. So it starts low. Right? So now at negative 1, what happens? Well, that factor only occurs one time, so I pass through it to the red dot. Okay, what happens at the red dot? Well, eventually I got to come back down because I get to that black dot down here that's now red at 1. At 1, what happens? The factor only occurs one time, so it passes through. Now I got to get back to 5, so it comes back up to 5. At 5, it only occurs one time, so I pass through 5 and I end high. So literally the same process that we learned at the beginning of the unit. The only thing that's different is we have to factor by grouping to get into factored form to find the X-intercepts. And again, I've told you this numerous times now, probably the hardest part in the unit is finding the X-intercepts. All right, let's go ahead and flip your notes over. So same thing, we want to sketch this. So if we can do the end behavior first, right? So it's 3x to the third. So it would be odd, positive, so it would be low to high. Right, because this is what we call standard form. Let's find the Y-intercept. So x is going to equal 0. So to find the Y-intercept, x equals 0. So you're going to have 3 times 0 cubed plus 9 times 0 squared minus 27 times 0 minus 81. So 0 plus 0 minus 0 minus 81. So your y-intercept is 0, negative 81. So now you have the end behavior and the y-intercept. So now all we need is the x-intercept. So we're going to let y equals 0. Now, in order to figure what the x-intercepts are, we have to factor this. Well, it's 4 terms, so we're going to factor by grouping. So I'm going to group the first 2, I'm going to group the second 2. So the first 2, right, I can factor out a 3x squared. That would give me an x plus 3. And then 27 and 81 are both divisible by 3. So I can factor out, let's go, minus 3. So you have x plus 3. There's a common factor of x plus 3. Factor that out. So 3x squared minus 3. Okay, again, talked about this. All of our factoring that we've learned still applies. I see 3 and minus 3. That means there's a GCF in that binomial. So I'm going to factor out a 3. I'm going to put it out in front. Please don't freak out. So now I'm there. That's a difference of squares. Perfect squares. So I have 3 times x plus 3. This would be x plus 1, x minus 1. So I had to factor by grouping to get it into factored form, which is what I have there at the bottom in blue. I started up with y equals. That was in standard form. Now the part there in blue is in factored form. So now we said that y has got to equal 0. So if we want, we can make this y, so it's a little easier to see. So y equals there. So y is going to be 0. So then that means we're going to set each factor equal to 0. So x plus 3 is going to equal 0. X plus 1 will equal 0. X minus 1 will equal 0. And again, why does the 3 in the blue equation not have to equal 0? Because it's 3. It does not vary. It will always be 3. The x is a variable. It's going to vary. So we got to figure out what it is equal. So we get negative 3, 0, negative 1, 0, and 1, 0. Those are my 3 x-intercepts. Negative 3, negative 1, and 1. And I have the y-intercept, and I have the behavior. So I have everything I need to sketch my graph now. So I start low. All right, we'll do this in a nice bright color. We go to 3. So what happens at negative 3? Well, that factor of x plus 3 only occurs one time. So I'm going to pass through it. Okay? Got to get back to negative 1. What happens at negative 1? That factor only occurs once, so I pass through. Down through 0, negative 81, back up to 1. What happens at 1? It only occurs one time, so I pass through. And there's my sketch. So when you're in standard form, I would suggest first you find the end behavior. Second, you find the y-intercept. And third, you factor and find the x-intercepts. And then the fourth thing would be, then you can sketch. No matter how you do it, though, you have to have the x-intercepts, y-intercept, and end behavior in order to sketch. You need those 3 things. All right, example 6, last one. So again, kind of weird notation. So the f minus g, right there where the purple arrow means, you're going to subtract the 2. So we're going to have x cubed minus 3x squared minus 4x minus 12. Don't forget, you're going to have to distribute the negative. So y is going to equal x cubed minus 3x squared minus 4x plus 12. So now there we go. So that equation there in pink, right, that I'm underlining here with blue, that's standard form. So we can get the end behavior, right? X to the third. So it would be odd, it would be positive. So it would be low to high. We could get the Y-intercept, right? The Y-intercept, x is going to equal 0. So if x is 0, this would be 0 minus 0 minus 0 plus 12. So that would be 0 comma 12. And if you're like, well, how's he getting 0? Plug in 0 for x. Those first three terms are all going to be 0. So you just get 12. So I have the end behavior and I have the Y-intercept. So all I need is the X-intercepts and I can sketch my graph. The problem is that's quite a lot of bit of work we got to do still. So again, as I'm looking at it, I'm going to group the first two terms. I'm going to group the second two terms. I can take out an x squared from the first two. And I can take out a minus 4 from the second. So there's a GCF of x minus 3. And then you have x squared minus 4. So that's what the equation is right now. But again, I told you that you got to be careful that you're still, all our factoring rules still apply. X squared minus 4 is a difference of perfect squares. So I can take it one step further. So y equals x minus 3. It's going to factor into two binomials that are going to be similar, other than the signs are going to be different. So this would be 2 and 2. So now to find the X-intercept, we're going to let y equals 0. So 0 equals x minus 3, x plus 2, x minus 2. So we're going to set this equal to 0, equal to 0, equal to 0. So my X-intercepts would be 3, 0, negative 2, 0, and 2, 0. So 3, 2, and negative 2. And notice each one of those factors only occurs one time. So that tells me that at all three of those green dots, my graph will pass through. If it would occur twice, then it would bounce off. Okay, so start low, come to the first green dot there at negative 2 that I'm coloring blue now. So at that dot, what does the graph do? The factor only occurs one time, right? Each one of them. So I'm going to pass through, come up to the 12, come back down. Now I get to the next X-intercept. At 2, the factor occurs once, so it passes through, back through the 3, and back up. And there's my sketch. So again, right, if you're in standard form, I would suggest 1, find the end behavior. 2, find the Y-intercept. 3, factor, find the X-intercepts. 4, sketch your graph. Again, what's going to be hard is step 3, finding the X-intercepts, because you're going to have to do some operation. Right now, the only thing we know is to factor. How do we know how to factor? It depends on how many terms. So make sure you go back, you answer the essential question at the top of your notes, write your summary, and then you'll be done with 3.5.